Hello everyone. In this module, we are going to concentrate on the state function enthalpy at constant pressure. We've already gone over the conditions of constant volume in a previous module. And in the real world though, we're really not at a constant volume, right? But at a constant pressure. Now enthalpy is going to be under constant pressure, and that's the heat evolved in a chemical reaction. And just as I said, it's a state function. So to refresh your memory, a state function, they are path independent. Now we've already introduced, or I've introduced, our internal energy, that state function, and that's a measure of all energy in the form of heat and work exchanged with the surroundings. Delta H is a measure of only heat exchanged under constant pressure. So delta H and delta E, they can actually be identical in value. So if the change of volume is small, not much work is exchanged with our surroundings. So these can be the same numbers, delta H and delta E, the same magnitude. Now, delta H and delta E can be similar in magnitude when our change of volume is large. When would that happen? A change of volume would be large, for example, if there's lots of gas produced or absorbed. But in many cases, we're interested only in the heat exchange, not our work done. If we're cooking food, we want to know how much heat is given off. We're not interested on the work done on the atmosphere by expanding against it. So we're going to take this expression, delta H equals delta E plus our pressure times our volume change, and we're going to simplify it. Okay, so delta E is going to be Q plus W, and if you recall, this P delta V is our work minus P times delta V. I want to substitute in my work for this, but it's not exactly the same, so I have to rearrange this. Minus W equals P times delta V. Now they're the same, so then I can just substitute this with minus W. So let's go ahead and combine it. So delta H equals Q plus W minus W. As you can see, these W's can cancel, so this simplifies to our change in enthalpy, which is equal to our heat at constant pressure, because these cancel out. So this expression simplifies to the change in enthalpy, which is equal to our heat absorbed or released at constant pressure. Okay, on to the next module.